Hi guys, today we are going to introduce our third and final technique to graph the equation of a line. In order for us to introduce that technique though, we got to talk about slope, okay? So slope is denoted by the lowercase m. What slope is, slope tells me how steep or flat the line is. Sorry for the stuttering, okay? So the steeper the line, then the larger the slope, and the smaller the slope, then the flatter the line looks. But the question is, how do we compare the slope of a line? How do we calculate the steepness of the line? To calculate the slope or steepness of a line, we calculate the ratio of how many steps we move vertically to how many steps you move horizontally. So how do I find the slope? Okay, slope, it's the ratio. So ratio, we can use the fraction bar or the word 2 or the semicolon. So slope, ratio of the vertical movement to the horizontal movement. The vertical movement, or how many units are you moving up and down, that's also known as the rise. The horizontal movement, or how many units you move side to side, that is actually called the run. Cool. Now, many moons ago, I used to go camping like a lot. Okay, I love trees. Cool. And then it said something like put your brake on 2 or whatever, because we have a pretty steep slope. But the question is, what does it mean that we're descending 6%? Okay, so we're gonna write 6% as a fraction, so it'll be 6 parts of 100. Okay, if we think about slope, ratio of rise to run, what this is saying is, well, if we're going downhill, we're descending 6 units, let's just say 6 feet for every 100 feet of travel. So we drop down 6 feet for every 100 feet that we travel. So I'm like, yeah, I should have remembered that. Okay, cool. Now we have some rules for slope, and I'll say that in a bit. Okay, so fun problem 1 reads, find the slope of the line graphed at right. Okay, so to calculate the slope of a line, we need to identify 2 points that are on the line. It doesn't matter which 2 points you locate. It would be nice if you have integer coordinates, so that way you don't have to estimate. Like, I wouldn't pick the point at x equals 1 because I really can't estimate that good. But points that are right on the money, we have one at 3, 4. We have one at 0, -2. Are there any more? What is this? -3, 0. And I think that's it. Okay. So to calculate the slope of a line, we need to identify 2 points that are on the line. I'm just gonna pick the first 2 that we see from left to right. And I always like to speak to myself, where am I gonna start counting from? So I'm gonna put uppercase P to remind me of the word point. And we're gonna highlight these 2 points. So I'm gonna put subscripts of 1 and 2. What if we switch the order? I don't really care. I label them as we see them from left to right because that's how we read from left to right. So I would like to read this graph also from left to right. Cool. What are the rules for slope? So where am I? So it says rules of slope. You have to move vertically first and then horizontally. So we're gonna go up and down and then side to side. Why is it that we gotta go vertically and then horizontally? Well, that's the only way we're gonna make sure that steep lines have large slopes and lines that are not so steep have smaller slopes. Okay, now, so we're gonna move first. So we calculate the rise. Okay, so rise, we calculate that by how many units are we moving up or down. If we're gonna go up, then we're gonna say that our rise is positive. But if we're gonna go down, then we're gonna say that our rise is negative. So after we go up or down, then we're gonna go side to side or calculate the run. Okay, if we pull to the right, then the run is positive. But if we have to pull to the left, then the run is negative. Fantastic. Okay, so we want to calculate the slope. Slope, ratio of rise to run. Okay, so what is my rise? What is my run? Okay, so if I start at point 1, rise, how many units am I gonna go up or down to be at the same height as the second point? So in this case, we have to go 1, 2. Let me just do these squigglies. Cool. We're gonna have to go down 2 units. Okay, and because we went down 2, then the rise is negative. So that will give us -2 over. What is my run? So now that we're at the same height, I want to know how many units are we going side to side to get to our mark. So in this case, we're going to have to pull to the right. We're going to have to go 1, 2, I believe 3 units. Let me do my squigglies. 1, 2, 3. I did too many squigglies, huh? Sorry, I don't know how to count with squigglies. Yeah. So we went 3 units to the right, and because we went to the right, then our run is positive. Okay. So 2 and 3 have no factors in common other than 1, so their slope is negative 2/3. So what this is saying is we're dropping down 2 units for every 3 units of travel. So we're dropping down 2 units. I only needed 2 squiggly, sorry. We're dropping down 2 units for every 3 units of travel. What if we had used this point and the point at 0, -2 and the point at 3, -4? Well, let's see. Are we dropping 2 units for every 3 units of travel? We're right here. Drop 2 units for every 3 units of travel. Oh, I'm nervous. 1, 2, 3. Yeah, so it goes to show it doesn't really matter because the steepness of the mountain is not changing. Fantastic. Now, just for kicks, I want to tell you some fun stuff about slope. Okay, so the slope should tell me when I read the slope, I should be able to how am I saying this? The slope should tell me how my graph should look, okay, as I view it from left to right. If my slope is positive, then the line should go up. If my slope is negative, then the line should go down. If my slope is 0, guess what? We're not steep at all, so the line should be horizontal. And if my slope is undefined, then we have a vertical line. Fantastic. Now, looking at our graph, is our answer reasonable? So I'm like, I don't know. Is our line going up? Is it going down? Is it horizontal? Is it vertical? So we have a line that's pointing down. So if the line is pointing down, then the slope should be negative. Is our slope negative? Yeah, so we totally nailed it. Unless like we miscounted. Fantastic. Okay, so let's go ahead continue our slope unit. Okay, so we have fun problem number 2, I think. It says find the slope of the line given find the slope of the line through the given points. And I'm like, well, wait a second, how am I gonna find the slope? There's no graph, unlike the problem we just knocked out. Well, that is correct. If a graph is provided, then you compare the ratio of rise to run. Okay, but if a graph is not provided, let's not worry. We can use the slope formula. Can we make our own graph? I wouldn't recommend it because we don't have graph paper. Okay, so the moral of the story is this: if they give you a graph, just compare the ratio of rise to run. If they don't give you a graph, then use the slope formula. Okay, so graph or not, to find the slope of any line, we need to locate 2 points that are on the line. Okay, so this is what the formula is saying. Okay, the slope of a line that passes through these 2 points. So all points are or ordered pairs are written on the form xy. To let the reader know that this is the xy of the first point, then we use the subscripts of 1. So we have x1, y1. To let the reader know that this is the xy of the second point, then we use the subscripts of 2, or x2, y2. So the slope of a line that goes through these 2 points is given by the following: m equals y2 minus y1 over x2 minus x1. So pretty much it's like difference of the y's or difference of the x's. And why is it y over x? Well, that's because it comes from our definition of the slope, ratio of rise to run. The rise, how many units are we going up or down? So that's gonna be like about the y-axis per se. Okay, run, how many units are we going side to side? Well, that's like the x action. So this is why we have y is on top, x is on bottom. Cool. Now coming to our problem, find the slope of the line through the given points. So with your permission, I'm going to label these. Since -3, 5 is the first point that I see, I'm going to call this my first point, or x1, y1. 1, -6 is the second point that we see, so I'm going to call that x2, y2. So with that being said, I understand that we have the slope formula in front of us, but we're not going to be given the formula on the test, and the only way that I'm going to remember it is if I write it down every single time that I have a need for it. If I have 5 homework problems, guess what? I'm writing it 5 times. So slope, we have m equals y2 minus y1 over x2 minus x1. So we got the formula nailed. Now we got to plug and chug. Oh, I ran out of space. I should have given myself more space. So that will give us m equals y2 minus y1. So that will give us -6 minus y1, or the other y of 5, over x2 minus x1. So that will give us 1 minus the other x value of -3. We got this. Difference of negative 6 and 5 will give us negative 11. Difference of 1 and negative 3 will give us 4. And the question of the hour is this: can we write it as a decimal? Sure. Can you write it as a mixed number? I wouldn't recommend it, but you gotta do what you gotta do. When it comes to slopes, ideally it would be nice if we had an integer slope, and if not, leave it in fraction form. That way we can identify the rise and the run more easily. Cool. Now, why did we talk about all this slope stuff? We talked about all this slope stuff because that is the only way that we can introduce our third and final technique to graph the equation of a line. This is my favorite way. Disclaimer. So at the beginning of the unit in a previous video, we had talked about different ways to write the equation of a line. One of them was standard form, ax plus by equals c, and a different way is slope-intercept form. So an equation is said to be in slope-intercept form if it looks like this: y equals mx plus b. But let's break down these variables. So in this case, if your equation is meant to have both x and y variables, then the x and y are the variables in your equation. M, well, M is a notation that we use for slope. B reminds me of nothing, but B represents the y-intercept. Sorry, you can't see that, but lucky for you, it's over here too. Alright, so with that being said, another fun problem, I think this is number 3. It says use the graph of the linear function to find the x-intercept, y-intercept, and slope. So a graph is provided, and we have to use it to identify the x-intercept, y-intercept, and slope. They're asking us to find 3 things, so we need to submit for credit 3 answers, and then write the slope-intercept form of the equation of the line graph. So we want to write the equation, and again, since there's more than one way to write the equation of a line, we have to be told which way, in which format do we write the equation: standard form, slope-intercept form. They want the slope-intercept form. Okay, so I'm gonna just answer this in the order that they asked me. X-intercept. Okay, x-intercept, point where the line intercepts the x-axis. Okay, so in this case, I think it's the same graph. Oh, I forgot to change it, sorry. Okay, so the x-intercept is the point where the graph intercepts the x-axis. Since the graph intercepts the x-axis at -3, then we're gonna tell the world x-intercept is at -3. Cool, let me go ahead, check that off. Second thing we want to find, y-intercept. Y-intercept, what is that? Point where the line intercepts the y-axis. So the line intercepts the y-axis at -2, so we're going to say y-intercept is at -2. Fantastic. Cool. Third one, find the slope. I think it's the same one it's the same graph we did. Sorry. Okay, slope. To calculate the slope, we want to compare the rise to the run, or we'll say ratio of rise to run. So to find the slope of a line, graph or not, we need to locate 2 points that are on the line. Okay, in this case, we already highlighted 2 points, and we're gonna use the ones from the intercept. So let's do this. So let me label these just like we did before, first point and second point, but I'm gonna put uppercase P. I put P because point. Do we have to label them? No, you just have to get the answer. Okay, so slope, ratio of rise to run. I don't really care if you start at point 1 or point 2, but I'm going to just start at point 1 because we read from left to right. So I like to read these lines from left to right. Are you going to get a different answer if you start from the bottom? You shouldn't, okay, because the steepness of the mountain does not change whether you go uphill or downhill, okay? But we're going to start at point 1. So a slope, ratio of rise to run. Rise, how many units are we moving up or down to be at the same height? So let me use my squigglies, okay? So to be at the same height, we have to go 1, 2. So in the earlier problem, I did too many squigglies because I did something that I don't normally do, okay? So to be at the same height, we're going to have to go down 2 units. So that means that our rise will be -2. Now that we're at the same height, how many units are we going to have to go side to side to be at our mark? So in this case, we're going to have to pull to the right. So our run will be positive. So after we drop down 2, we're going to have to go 1, 2, 3 units to the right. Okay, to the right. So our run will be +2. and then we can't reduce it, so we're good. If we use our number sense, if our slope is negative, then the line should point down. Yeah, it's pointing down, so we're good. Okay, cool. So we answered the first three. Then it says use the slope, write the slope-intercept form of the equation of the line graph. Okay, so we want to write the equation of this line, and they want us to write it in slope-intercept form. So an equation is said to be written in slope-intercept form if it looks like this: y equals mx plus b, where m is the slope and b is the y-intercept. Cool. So lucky for us, we have already identified the slope. So it's negative 2/3. What are we going to do to the slope? Multiply it by x. And then what are we going to do? Add to it b. Add to it the y-intercept. The y-intercept is at negative 2, so we're going to add negative 2. Now, if you box this, I will be proud of you, but I will love you more if you present it to me in a much cleaner format. We're going to write this as negative 2/3 x, and instead of writing plus negative 2, I would appreciate it if you put minus 2. I want your answers to be as clean cut as possible. Cool. So at the beginning of this video, we had said we were going to introduce our third and final technique to graph the equation of a line, but we have yet to graph an actual equation. Well, that's because we had to talk about a lot of things before we can talk about our new way, and the new way has arrived. Cool. So let's go ahead look at our fourth and final fun problem. So it reads, write the equation in slope-intercept form and then use the slope and y-intercept to graph the equation. So I want to point out that we cannot graph this using the technique of our choice. First, we have to write the equation in slope-intercept form. So y equals mx plus b, or like in English, solve for y. And then once we do that, we have to use what? The slope and y-intercept. What are we going to use those pieces of information? We're going to use that to graph the equation. Oh, I should have gave you space. Okay. All right, so let's go ahead do the first part. Let's go ahead put this bad boy in slope-intercept form. Let's go ahead solve for y. So we're going to add 3x to both sides. And that will leave us with 5y equals 3x plus 35. Cool. So we want to solve for y. So to get rid of the times 5, let's go ahead divide both sides by 5. Sorry, technical difficulties here. Alright, so let's go ahead divide both sides by 5, and I'm really against the long fraction bar because students don't tend to actually divide both sides when they do that. So when we do that, will leave us with y equals, and you can leave it as 3x divided by 5, but I don't recommend that because then you won't be able to see the coefficient of that variable term. So I recommend you write fraction times x. So we'll put 3/5 times x, and then plus 7. Fantastic. So we did the first part. Whew. So now let's go ahead use the slope and y-intercept to graph the equation. Because this is in slope-intercept form, then we can quickly identify the slope and the y-intercept. The coefficient of the x term will give us the slope. So I'm out of space. I'm going to do it right here. So the coefficient of the x term is 3/5. So our slope is 3/5. So we're going to put m, or slope, equals 3/5. Whatever the constant term is, that's our b, or y-intercept. And because b reminds me of nothing, b does not remind me of y-intercept, for the time being, I'm going to put y-int. Okay, so the constant term is given by 7, so our y-intercept is 7. Okay, now to add to our number sense, since our slope is positive, I'm like, oh, positive slope. Is the line supposed to go up, down, horizontal, or vertical? So if I can read your mind, hopefully you said like, oh yeah, it's gonna point up. Okay, so if our graph is not pointing up, then we're gonna have a situation. Cool. So now, where do we begin to graph? So the slope is not in ordered pairs, so it's more like directions to get to our next mark. The y-intercept is 7, so it's like, oh, if the y-intercept is at 7, then the line should intercept the y-axis at 7. So let's go ahead locate 7 on the y-axis. Now we're going to use the slope of the line to locate a second point. So remember, slope is the ratio of rise to run. Okay, so how many units are we going up or down? And then we're going to compare that to how many units do we go side to side. So if our slope is, if our rise is +3, then we're expected to go up 3. And if our run is +5, then we're gonna go 5 right. So let's go ahead, apply the directions from where? From whatever point we have graphed. So let's do this, up 3 and 5 to the right. But as you can see, we don't have enough space to go up. The axis is already labeled, so we cannot adjust it. So we're gonna have to have a backup plan, plan B. So it's like, our original plan was to go up 3, but that's not gonna happen. Change of plans. We're gonna have to go down 3, and going down 3 translates to -3. And if we're gonna change the directions to the top, yeah, we're gonna have to change the directions to the bottom. So original plan was 5 right. Just kidding, 5 left. So that will leave us -5. So you can always rewrite the slope. Rewrite means what I just said. Write it differently, but it's still gonna simplify to the same thing. Negative over negative is positive. So we still have an undercover +3/5, and then we should still have a line going up. So if I apply the slope in this format, so down 3, 5 left, let's do this. Down 3, 1, 2, 3, and then 5 left. 1, 2, 3, 4, 5. And if I counted correctly, then we should be right on the mark. When we connect these 2 points, look, we should totally have a line going up as expected. So let me go ahead, take my straight edge, connect these points, and call this video a wrap. So yeah, so did we address everything? Write it in slope-intercept form, use the slope and y-intercept to graph. Well, we used the slope and the y-intercept to graph. Yeah, we did it. Fantastic. Okay guys, so this video concluded our third and final technique to graph the equation of a line. If the directions just say graph the equation and no other indication, then you have your choice. You know, you can use a table of values, you can use the intercepts, or you can use the slope and y-intercept. But if the direction says use this technique or else, then guess what? You have to use that technique or else. Okay, this time I mean it. Bye guys.